Welcome to our YouTube channel. In this video, we are going to model a substation gantry structure in STAAD.Pro. Modeling a substation gantry structure in STAAD.Pro will take more duration. Also having more contents or more topic to be covered. So we had divided this entire substation gantry structure modeling in STAAD.Pro as 3 stages. This is the first stage out of 3. In this stage, you can find out the introduction, the principal drawing which we are going to use for modeling in STAAD.Pro. The contents where will explain what are the activities involved to perform the substation gantry modeling. Gantry structure philosophy. Here we had given a reference of a YouTube video, one of our YouTube video, to understand more about gantry structure philosophy and their components and their loading parameter and the software to be used. Next, we are going to create tower, nodes and members. Finally, the support condition. With this stage 1 of 3 get completed. Watch also our other 2 stages so that you can able to understand and perform modeling of substation gantry structure in STAAD.Pro. The link for other 2 videos you can find in description. So this is a principal drawing which we are going to do model in STAAD.Pro. So you can see the elevation which is showing the girder span and the tower height. So the total tower height is 21 meter, whereas the tower height from the base and to the conductor fixing point is 16 meter. Above that it is 5 meter. Depth of the girder is 1.2 meter and width of the girder is also 1.2 meter. The total bay distance, that is the center to center distance of towers, is 16 meter, which is having the girder of 16 meter span. The conductor fixing point is call it as a face to face distance. The face to face distance is 4 meter each, and from face to earth distance, that is tower center line, is 4 meter. So this is a configuration of a preliminary drawing which is related to electromechanical drawings. In the plan view also we can see the same thing. The base dimensions of the tower is 3 meter along the conductor span and 2 meter along the girder span. So you can see in the elevation it is 2 meter in girder span and 3 meter in conductor span in section 1-1. Now the girder and the tower to be segmented based upon the splice and cross bracing. Generally that available sections in market with the suppliers, steel supplier or manufacturer is different. We need to check those the maximum span. Generally that steel profile which are available with a minimum span of 6 meter to maximum of 12 meter. Some supplier having the restriction span of 6 meter alone. Some who used to have maximum span of 12 meter. So we need to check and we need to do the splicing accordingly. If the supplier is having 12 meter span, then the splice we can reduce to 2 or even to 1 number, because the 16 meter is that we need at least 2 number of splicing. The maximum length of any section, that is profile, means that angular member which used to have it is a 12 meter only. So in this case we can consider the supplier are having only the limitation of 6 meter length of each profile. So the main leg to be spliced accordingly. So here if you see in the tower there are 3 splice, 5.6, 5.9 and 5.7. In the girder it is 4.8 and 5.2. So these all the splice are within the limit of 6 meter. So we can go with this model like this. And the other leg member height is 3.8 meter for peak of the tower. So likewise we need to make the segment of splicing for main leg members. Similarly for cross bracing also we need to do the segment. So these are the green color from the base of the tower is a cross bracing for group 1. For group 2 is a blue color in the mid of the tower. Again for group 3 it is green color. And finally the group 4 we can consider as red color cross bracing in peak level. Similarly, like for girder also we need to do this cross bracing as a group of one is magenta color, another one is blue color. So likewise we are having a two group of bracing members, and all the node to node distance of cross bracings are divided into equal parts. For example, here the base and conductor fixing height are 16 meter. The 16 meter is divided into 10 parts, and so that the start and end point of each cross bracing is having 1.6 meter. So here in the peak area, again it is divided into equal part. So 950 each. So similar like girder from the tower end, it is 1.13 until the first phase. Also same in right side of the girder. Similar like all the mid span, that is face to face distance, we are having equal distances 1 meter each. So these are the general principle drawing which we are going to use for modeling in STAAD. So these are the content of this video which we are going to look. Number one is a tower model which we are going to make using by creating the axis of the tower based upon the picture which we had seen earlier. And in that tower model we are going to assign member properties such as the sizes of the members and gamma, the rotations of the member, and we need to assign the some members to be as a truss member. I will explain during demonstration. And we have to assign some members as a dummy member where it cannot take any loads, and even it won't have its own self weight. So likewise we need to develop some dummy members also, we will see in the video. And segments, we need to segregate the various structural members based upon their structural arrangement. Like segments we need to provide like different type of panels and different levels of splice connections, so that we need to prepare. And renumbering and grouping of members we are going to look how to do it in STAAD, and how to create the grouping in members and nodes also we are going to look. Support conditions, that is a boundary condition of any of the structure, is very important to analyze the reactions due to applied loads, so that we are going to see in this STAAD model. And finally the girder model. After once developing the tower model, we are going to develop the girder model using the same methods which we are having earlier for tower models, like segments, member definitions and grouping. So these parameters we are going to consider. Even the truss also we are going to include here in that girder model. And after completing this tower and girder, we are going to do additional base. Bay is nothing but it is a two number of towers having a one girdle. So this arrangement we used to call it as base, which used to support for three phase girders, three phase conductors. So additional bay means we are going to extend this same two tower one girder for single bay to additional 2-3 bays. How to do it in STAAD model we will see. This is a screenshot of one of our YouTube video. This will explain you the design philosophy of substation gantry structures. In this video, you can find the preliminary input, components, structural configuration, design procedures, design loads, design optimization techniques, and applicable tools and softwares which are required for substation gantry structures. Watch this video before going for modeling so that you can understand what is a substation gantry structures. The link to open this YouTube video is provided in the description. You can find from there. This is a window view of STAAD.Pro when we are opening a new file. There is a two images on the screen you can see. The left hand side image is a longitudinal section of gantry tower in height wise. So this is first image in the left hand side is the tower height view in conductor spanning direction, so that the base is 3 meter here, and in the right hand side image is a tower height view in girder span direction, so the base dimension is 2 meter. So these are the two images which we are going to make as modeling here. In the right hand side of the edge of the STAAD model window, you can see a table which is showing the X, Y, Z view. In that, the unit of measurement is mentioned in inches. That is a FPI systems of unit of measurements, feet, pound, and inches. But we are going to make a model in SI units. That is a meter, kg, or kilonewton, and second. So for that, we need to change the specification of this unit of measurement. So for that, we need to go set units of measurements. In that, we need to right click on the STAAD screen model, click the display option. So this option window we need to modify for SI units. So start from the structure units. We need to change this for dimensions. It should be meter. For displacement, you can have it in mm, and linear it is kilonewton per millimeter. So it is kilonewton per meter. So kilonewton meter per degree is a rotation, and kilonewton per meter square by meter is a section modulus. So likewise we are changing here, and weight also we can consider as kg, and we can change the decimal point to 2 if we are having 3 or 4. And section properties is millimeter square already default. We can reduce it to 2 decimal point. So we can check whether all those are in SI unit. Here the density is in FPA unit. So we can change this to kg per meter cube, which is a SI unit. And force units also you can change here as kilonewton, distance force kilonewton meter, moment kilonewton meter, distribution moment, stress. So stress we can have it in a Newton per millimeter square or megapascal. Velocity meter per second, acceleration per second square. So degree, here also we can reduce to then next one is a dimension. Okay, so still this not changed, so still it is in inches only, the table in the right hand side. So where, yeah, here the dimension is not changed. So again selecting here and apply. So now you can see here the inches had changed to meter. Even some of the case this table won't be appear, only this window may be available. What can we do in this situation? So for that we need to click the main ribbons like view or specification, where there will be some changes here. Some table which are related to the main menu will appear here, but we want the table for nodes. So you can again click any workflow here in the left side. So it will prompt some window, small window. So you can click simply OK. Now you can find here the node table. So now our STAAD window is ready to create the model. So first one is we need to create the nodes. So as we see the sectional views here, we need to create the node from the base. So first we can start from 0, 0. Next one is 2, 0, 0, as the base width in one direction is 2 meter. Now 0, 0, 3, as a base width in z direction is 3. Now x is 2, and again y is 0 and z is 3. So likewise we need to create the geometrical nodes. So now we can what we can do is we have to have some calculations in Excel sheet, so that all the nodes we can able to create in a way we can just copy and paste the Excel values. So from the fifth node, what I had calculated is from the center, from the base to the girder connection level, we used to have some dimensions. At the base we are having 2 by 3 as a dimensions of the tower. At the girder connection level at 16 meter, you can see the image, there is 1.2 meter, so it is going to reduce. So what we need to calculate is 2 minus 1.2 divided by 2, we will be getting the node point of the girder connection point. So likewise we need to calculate in Excel sheet. So I had calculated already, having the backup. I'm just copy and paste the 5 7 5 6 7 8 nodes. So that are the bottom of girder fixing level, and for top also same thing, only the height is going to change, whereas here y you can see it is a 16 meter, that is a girder fixing point, and above that again with the same sizes, only the y is having 17.2, that is 16 plus 1.2. You can refer the image. And the 13 node is a top node. Generally for gantry structure, at the top peak location, there must be some gap between the four angle which is going to meet at the top. So that gap should be maybe 150 mm or 200 mm, whatever we can able to consider, we can consider. So that is that gap to be filled with the bent plate in practical. So we are making a 200 mm of that model. So now the tower main nodes are created, you can see in the screen. So you can click on your keyboard shift plus N to view the node numbers. So here is a node numbers. So before going to add a member, we can check the dimensions, whether we had created the exact node which is required for gantry structure. So in X direction it is 2 meter, refer to the image and the picture earlier shared. As it is a taper, there may be some difference in mm. So while measuring this dimension, we are having the 16.03 meter. So here it is a straight, so it is 1.2 meter, and you can find the width of the girder also, it is 1.2 meter, and from girder above it is 3.87 meter. As it is a steep slope, it is coming difference in 0.87, sorry, 0.07 meter, that is 70 millimeter. And at the top we had created 200 mm. So likewise we can check the measurement before going for adding beams. So now we can remove this dimension by clicking the utilities, node tools, and remove node to node distance. So these features are available in STAAD.Pro Connect edition, not in other version or old version. So now we need to create beams. For that we need to go geometry, add beams. So from here 1 to 5, 3 to 6, 2 to 7, 8 to 3, then 5 to 9, 9 to 10, 7 to 11, 10. So now all the main members are created. So you can view, so this direction the base width is less. So here now you can see the perfect view of, you can press again shift N. So you can see the perfect view of main legs. So you can, now we can connect with more members. So main legs are created from top to bottom. So now we need to create the tie member at girder fixing level. Also we need to create the cross bracing. We need to create the dummy member. These are the dummy member which we are going to create at the top of the tower. Next we are going to create the bracing members. For that we need to do segment, or we need to divide this main leg. Select this main leg and right click insert node. So we already discussed that we are going to split this entire 16-meter height to 10 divisible, so that we will be getting 1.6 meter. So in this STAAD model, that n point we need to enter 10 minus 1. So it is 9 number of node point we need to create. So here you can see the nodes are created. You can also check the dimensions by clicking utilities, node to node distance. So it is 1.6 meter. So everywhere it is 1.6 meter as shown in the image. Now again we need to split this main leg at peak level in a similar way by selecting the member and right click and click insert node, add n points. Here we are having 4 number of divisions. So for that 4 minus 1 equal to 3, we need to add it here. Again you can check the node to node distance, utilities, node tools, node to node distance. So which is 970, as it is a sloped, it is showing 970. So which are same, more equal to this 950 mm. We need to add beams for bracing. This step is more time consuming activity. So let we see one by one. But due to the time consumptions, I will be neglecting some part to show in this video. So you need to keep this view in plan first and select the members from the apex. So we don't want this portion. So you can view, go to view and click selected objects here, so that other members are hidden. Again you can select here. So now if you click this elevation view, so it will show like this. Now it is easy for you to draw the bracing. So go to geometry, add this. So likewise we need to add until the top. It is added now. Again in other side also we need to create this. Now we had created one side. So next one is other side we need to create. Go to view, click display whole structure. Now again keep the view in top view. Now again we need to select other side, opposite side. View, selected objects. Again in view, selected objects. So these are the members which you not required. So now you can see the elevation view with the main leg alone. Again go to geometry and add cross bracings. Now in the opposite side also we got created. Next is we need to go for adjacent sides also. So next, now display whole structure. Select the top view. Again select the same this side. Now the entire cross bracings are created. So that is showing here. If you look in the X direction, that is front view, it is showing like this, similar to the image which is showing in the right hand side with the 2-meter base. If you see the other transverse side, it is showing 3-meter here. We can also measure here. Utility, go to node, with 3D. So 2-meter in the X direction and 3-meter base in the Y direction. So now we had created the perfect tower model, but this model is still, we need to work more in that to add support reactions. So for that we need to go specifications, click this pinned, add, select this S2 support to 2, which is a pinned one. You can find the information about the support by clicking double time. So it is fixed, enforced, pinned. So this is support number 2. Now we need to select the node point in the main window. 1, 3, 2, 4. So 1, 2, 3, 4 are the node for support reaction, which is a pinned. So now the support condition also provided. Thank you. Look description for more related videos. Subscribe to this channel for more updates. Thank you.